I'm going to talk to you today about your BTEC and Design and Technology options that you're choosing at the moment, and this is about the BTEC Tech Award in Engineering. What's really key here is that design and technology, technology and engineering contribute potentially huge amounts to the British economy. 27% of enterprises in the UK are engineering related, and there is a 59,000 shortfall in the number of people that are coming out with the skills to go into engineering. Now, whether that be through a BTEC in engineering or a GCSE in design and technology, 59,000 people are required just to fill the jobs that are out there. Now, this report comes from 2018. Here we are in 2020. Probably the shortfall is going to be even greater, and potentially coming out of the COVID crisis, we're going to need an even greater input in putting our infrastructure back together. So huge employment prospects from design and technology and from engineering. Where will the jobs be in engineering? Well, aerospace, built environment, cybersecurity, food and drink, water, flood risk. The list is endless, and as I showed you if you've watched the design and technology presentation previously, almost any sector is going to require skilled technical people who are able to think differently. And by taking one of those qualifications, whether it be a DT, GCSE or a BTEC in engineering, it really sets you up for really positive employment prospects in a huge range of sectors, both within the UK and within Europe and internationally. So well worth studying. So to talk specifically about the BTEC Tech Award in Engineering at Level 2, it's made up of 3 components. Component 1 is 30% of the course, component 2 is 30% of the course, and component 3 makes up the remaining 40%. Like any BTEC, there are assignments which you complete, and they're ongoing throughout the 2-year course, and those will lead you to your final qualification at a pass, merit or distinction level 2. The component 1 is exploring engineering sectors and design applications. You will learn about different engineering sectors, that's aerospace and marine and electrical and manufacturing and mechanical, and the sorts of jobs and career progression that go within those. You will then need to create an assignment where you talk about how different engineering companies at different scales work together to produce an end-engineered product. Now that might be very small scale engineering in a one-off jobbing workshop, or it might be mass engineering, building rockets and building satellites and building aircraft, or marine engineering, building huge boats. So there's all sorts of things to look at there. In component 1, the learning aim B, you actually do a design activity where you look at a flat pack light, and you're given the design brief that you have to analyse. Then you have to come up with some drawings. You then do some computer-aided design work, and as a team of people you decide on improvements and you present those. Potentially you output those. Actually there's no necessarily any need to output them, but we tend to do that so that you end up with a finished product. This is very much a project that we run in year 9, so you should have the sort of the skills and understanding to really nail this part of the components to a very high standard. Component 2 is investigating an engineering product and investigating the processes, the materials and the properties that go into manufacturing that product. As an engineer, you would need to be able to select tools, equipment and processes that are appropriate for your activity, and so you need to know about those and you need to do the research into those, and you would focus on a single product and look at how it's made, but at the same time you have to do your wider research and investigation into materials, processes and properties. Second part of that component, you actually investigate a product by taking it apart, you disassemble it, and you look at what those components are made from. We focus on a multi-tool from a bike, and that's made up of components which are injection molded, pressed steel, extruded materials, bought-in components which are called proprietary components, and then you look at why those are used and why they're selected by the engineering company. Then you produce a production plan, and you move on and you actually create your own product, making a replica of one of the things that you've analysed before, and you carry out your own quality control checks to go with that. Component 3 is a written exam. It actually happens over the course of 1 week in 2 sessions. One of the sessions you spend conducting an experiment, very much like you would do in science already, where you do these required practicals. You are shown the experiment, you're shown how to set it up, and you're then told how you've got to interpret that data. So whether you're drawing graphs or you're filling in tables, you're talking about why those materials or why the results of the experiments are what they are. It's very timed, it's under controlled conditions, and it's in a sort of a written exam format. Now remember, this is 40% of the overall course, so what you get here really does make a difference to what your overall grade is. The second part of that paper, you're looking at a particular component, and you would be looking at the technical drawing that goes with it. You'd be looking at the table of results of quality control checks that have gone on, and you try and identify any manufacturing problems and make suggestions about how to improve it. So you need to have that understanding of materials from before, and that brings all your design and technology study at Key Stage 3 to bear as well. So this one is about interpreting data. Okay, so that's the end of that presentation about BTEC Tech Award Engineering Level 2 qualification, and if you remember it's a great opportunity for filling the skills gap in the UK.